Hey folks, this is Captain Jones here to talk to you about Lab 1. At this point, you should have downloaded Logisim, and you should be familiar with that program. If not, you can watch the video that I recorded to introduce that to you. In this video, I'm going to show you the circuit that you're going to be working with for Lab 1 and describe what you'll be doing and what you're going to turn in when you're finished. You'll need two files to complete that lab. They are linked here, so that's a starter circuit and a file that kind of represents our multiplication program. When you open that file for the lab, you should be greeted with this here, which is basically the first circuit that I'm going to recommend you work on. To kind of show you where this is located, what I'm going to do is double click up here, the main circuit. So top level circuit here that we're working with has got a clock and a reset button going into our LC3 computer. And if I double click that component, I am greeted with a circuit which should hopefully be reminding you of this diagram right here, because that was my inspiration, right? I've got a processor bus going all the way around, my control unit on the left, my processing unit on the right, with my memory down in the bottom left-hand corner, and that's what I tried to replicate here, right? I've got my control unit, my processing unit, my memory, three big components from my LC3 computer. We're going to ignore the inputs and outputs for this unit. We'll get to them a little later. And I've got a whole bunch of signals that are connecting them. But hopefully this is hopefully you kind of know what you're looking at, and even though you don't know what these exact signals are, you know that there's some stuff that needs to go back and forth between these units. All right. The ALU, like you might expect, is here in the processing unit. So I'm going to double click that and show you that this is kind of a replication of this pink box right here. Right, I've got my registers going into my ALU, and a little multiplexer that controls whether the B input to my ALU is coming from my register file or from my instruction. And then if I double click my ALU, I'm back to this blank circuit here. So like I said, this is the first one I'm going to recommend you all work on. What you need to do is add some components in Logisim to be able to implement the ALU for the LC3. And you'll know you're complete if the ALU-K signal, when it takes on these different values, the result C follows these expressions. So when ALU-K is 0, 0, C is the result of A plus B. When ALU-K takes on the value 0, 1, C is the result of A and B. When ALU-K takes on the value 1, 0, C should be the result of not A. And when ALU-K is the value 1, 1, then C should just be the same value as A. All right? So add some components to that to make it work. That's your first circuit. Number two, the next one I'm going to recommend working on is here in the control unit. So I'll double click this and scroll down a bit to this little box here called logic. All right, so this circuit is implementing everything in the left pink box here for my control unit. The logic portion is this block of combinational logic, which is reading from the processor bus, and it's setting these three flags or condition codes based on the value on the processor bus and whether that value is negative, 0, or positive. Okay, so if you double click the logic circuit, there's nothing in here. What you need to do is add some components that read from the bus, in which on our output set bit 2 if the value on the bus is negative, set bit 1 if the output the value on the bus is 0, or set bit 0 of the output if the value on the bus is positive. Right? And if you're not sure kind of how you might start approaching that, my recommendation is going to be to take something, a small number like a 4-bit number, and write out all the possible 2's complement values that 4-bit number can take on, so -8 to 7. And then looking at all the binary values, see if you can figure out what's similar about the numbers that are negative versus the ones that are positive, and think about how you might test a value if it were 0. So once you complete that, that's your second circuit that you're going to do. And the last one, you might have seen it as I was scrolling through, is going to be this portion of the control unit. So in my control unit, actually I'm going to skip to my other data path right now. I've got just some sine extenders, some zero extenders, some multiplexers, some adders that kind of form the control unit, everything in the control unit that's not in the finite state machine. All right, so I've got the finite state machine implemented here in the control logic, and all the control signals that we're going to need to implement this early version of the LC3 coming off the side here. So what you need to do is kind of fill this in, right? Fill in, the wires that are coming out the instruction register and where they're going and how they're connected to the other components. One component I didn't mention last time in the intro to Logisim is this one right here. You can find your tri-state buffer under the gates folder It's called the control buffer. So that's your tri-state buffer. Alongside the FSM, I've got some components that are already in here for you to kind of help get you started. Number one is the instruction register right here, which you can already see wired up with the load signal, the clock, and the reset, and that's coming in from the processor bus. And I've got a little example about how you might take the instruction register and sort of carve out, certain bits of those signals to go to, tunnels or to outputs, right? But you'll need to add, some other splitters here and the rest of the stuff to kind of complete this this part of the circuit. While you're navigating this circuit, I want to recommend trying not to use the little menu on the left, even though I've been doing that a little bit here. The reason is because when we start simulating this, the Logisim can get a little weird if you are, for instance, trying to get into the control unit by double-clicking this component or by clicking the control unit icon. Those can actually be kind of like separate instances of the circuit based on sort of like one's being simulated and one's not. So what I'm going to recommend you can use the control left arrow, like I'm doing right here, to kind of back up one in the, or go one level higher kind of in the circuit hierarchy. And then I'm going to recommend doing that and then just double clicking on the component you want to access, and then control left back to where you need to go to kind of move around. So as you're testing this, the simulation should be enabled. Every time you want to test it, I would recommend resetting it, and then what you'll need to do is go in here to the memory, and this should be in there for you. This is our memory for the LC3. You're going to right click and select load image, and then select the multiplication program that you downloaded as part of the lab. All right? And when you see that, you should see these values here, which are implementing the multiplication program from Chapter 4. So a very basic program to just let us test the LC3. All right? Once this is ready, what you can do is start pressing Control T to toggle our clock. And if things are working as we're toggling this, then stuff should be happening, right? I should be fetching items out of memory. I should be, loading those into the instruction register. And I should be able to kind of watch things go through my LC3 as it's being manipulated. One kind of weird thing about this circuit, I'll let you know right now, is that when the machines reset, you end up having to press Control T 4 times before you'll actually get to sort of the first fetch. And if you're curious why that is, I can show you later. But just kind of know right off the bat, I should be able to press Control T 4 times, and then sort of I start my my processing. I'm trying to think there's a good way. Oh yeah. So what I'm going to do is jump into, this is my solution. Hopefully I don't show you anything untoward at this point, but I'm going to go into my memory and see if I can show you kind of that in operation. Right. Okay, so I'm loading this. Start up a simulator. I'm going to press Control T 1, 2, 3, 4 times, and then so now you can see the load MAR register is set. I'm loading the initial value on the program counter, which is 0, right? Because I'm trying to get the 0th value, and now I'm executing that. I'm going to load that into my memory data register. You can see that here. 2206 is the very first instruction. And then I'm placing that on my processor bus, and that should be going into my instruction register, and that's just kind of showing you the first couple of cycles of this circuit working. All right, I chose this program because you should be able to see. I think it loads. If you go here to edit contents, you can see the whole memory. So it loads 5 and 4 by default. So you should be able to complete those 3 circuits I pointed out, and then run this program and see that multiply happen in the register file. And feel free to play around with those. You can change those values to whatever you want from inside here, from 5 and 4 to 0, 4, 3, 0, 0, 1, 0, to play around with that multiplication. When you're finished, you got a couple of things you kind of do if you want to go further. All right, so I made for instance, one change to the program. I changed the halt instruction to something different. So what you can do is take a look at that program and see what it is and what it's doing. In your file, I also included, let's see, a couple of circuits that are shells, processing unit shell and register file shell. And that's if you want, you can try to not look at my picture or my circuit, put your stuff in there and see if you can kind of build those yourselves. When you're finished, what you're going to do is just send me your completed circuit file. All right, that's all I got. Hopefully that one makes any sense. If not, ask me any questions. Otherwise, I'll see you next time.